Alright, in this example, we have an insulated piston cylinder device initially contains 1.8 kilogram of saturated liquid water at 120 degrees Celsius. Now, an electric resistor is placed in the cylinder, is turned on for 10 minutes until the volume quadruples. This is a constant pressure process. Determine the initial and final volume of the cylinder and the electrical power rating of the resistor. So again, first analyze the problem. So your system is water. It is important to identify that because we know that we're going to take a look at water tables. Then they say it's insulated. That means there are no heat interactions. It's a piston cylinder device. I expect there might be some boundary work. And they give us the mass and they say that it is saturated liquid water in the first state. And they're also giving us the temperature. Okay, there is electric work being done on the system and they're asking the volume and the power rating of the resistor. Okay, so first things first, figure out what they're asking for and how you can calculate those. So they're asking us to calculate the volume. And for me to be able to calculate the volume, I can use the equation, which is the volume is equal to mass times specific volume. So that means I need to first figure out what the specific volume is. And therefore, let's look at the first state and then let's see if we can figure out the specific volume from the tables. Okay, so at the first state, they are giving you not the pressure, just temperature, right? But they also say that is a saturated liquid. So that means that you need to look at the saturation table for water, and from the temperature table, locate the temperature 120. And since you have a saturated liquid, then you should be at the saturation pressure at that temperature. So the pressure is 198.67 and the specific volume will be the saturated liquid specific volume, which is 0.001060 meter cube per kilogram. All right, so therefore you can figure out the pressure to be 198.67 kilopascal, which is also equal to the second state pressure because the pressure remains the same. And this is equal to the saturation pressure at 120 degrees Celsius. And we also read what the specific volume at the first state was, and that is 0.001060 meter cube per kilogram. Now we can figure out what the volume at the first state is because I know it's gonna be mass times specific volume, and mass is given to us 1.8 kilogram, and therefore it is 0.001908 meter cube. Okay, and we know 4 times of the initial specific volume is gonna give us the specific volume at the second state, right? Therefore 4 times of this is gonna be 0.00424 meter cube per kilogram, because that is what the problem says. Volume quadruples, that means 4 times of the initial specific volume is going to be the second state specific volume, right? Okay, so but they're asking us, of course, the find the overall volume. So that means you need to multiply this with the mass. And this should give you 0.008, 0.007632 meter cube. Okay, so we figure those out. All right, so the next thing they are asking is find the power rating. And they are giving us time. That means that if we can actually find the electric work from the energy balance, then divide it into time, then we can get the power. Therefore, how we gonna get the electric work is from the energy balance, right? Because electric work only exists as a term in the energy balance. So let's write down the energy balance and see how we actually can figure it out. So let me see. Let's add another page. Okay, so first of all, we need to analyze the system and identify energy interactions. So there is electric work and there is boundary work, right? So the electric work is getting in and the boundary work is getting out. And this is equal to the change in the internal energy of the system. And in a constant pressure process, we know that we can combine boundary work with the internal energy change and write it in terms of the enthalpy change. That means if I can actually figure out the specific enthalpies, then it will lead me to the correct path, right, of calculating the power rating. So basically, then let's look at analyze state 1 and state 2, and let's see if we can figure out H1 and H2. So we already checked state 1. So H1 is equal to HF, and we use the same table. Okay, so H1 is equal to HF is equal to 503.8 kilojoule per kilogram. Okay, we figured out H1. So to figure out H2, let's see, at state 2 we have the pressure, and we have the specific volume at the second state. Together, these data will tell you that you actually have a mixture. And if you have a mixture, how you're gonna figure out what H2 is? You through using quality, right? HF and HFG, I can read from the same tables, okay, but for the quality, I need to figure it out for the quality, and quality can be calculated through the use of specific volume, because we know the specific volume of the mixture, which is 0.004 0.00424 minus 0.001060 meter cube per kilogram over 0.89133 minus 0.00106. So this will give you quality to be 0.003572. And once you figure out what the quality here is, now you can calculate what H2 is. Which is equal to 511.7 kilojoule per kilogram. Now we know H1 and H2. I am able to put it in the energy balance to calculate electric work, mass times H2 minus H1. And then you calculate this to be 14.202 kilojoule. Now they're asking for the power, so that means you need to get the work and divide this to time to be able to calculate the power, right? So this is 14.202 kilojoule over, it was 10 minutes. 10 minutes is, since 1 minute is 60 seconds, it's gonna be 600 seconds, and this is gonna be approximately 0.024 kilojoule per second. In other words, 24 watts.